Okay. Okay, so let's we start our course today, yeah? Okay, Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for coming today. Okay, so we still continue our topic, yeah? Discussing about hypothesis testing, yeah? Hypothesis testing. Actually, we can apply many situations in terms of hypothesis testing. Yes. Before we continue, maybe some of you has questions or opinions, something. Is there any unclear explanation? Yeah. Okay. If no, or no response, okay, no problem. Okay. Okay. Oh, what's okay, izin ke toilet. Okay, no problem lah. Yeah. Okay. Yeah. So we continue. Yeah. So today, yeah, actually, last time we already talked about how to determine or how to test some observation using statistical tests. Yeah. So you already familiar with significant level, critical region, critical value, something like that. Yeah. So we now arrive, still continue. Yeah. Last time we discussed about this case. And then we continue a new topic here. The use of p-value for decision making in the testing hypothesis. Yeah. Maybe the new term here is about the p-value. Actually, what is the p-value? Actually, what is the p-value here? Technically, yeah, technically or literally or technically, yeah, technically p-value is equivalent to the significant level, yeah, significance level. And why? And then why? If it is equivalent or it is same, and then why we should name it into different? Yeah. Okay. Actually, we can answer these questions in the motivations. Okay, but before we going to the motivations here, please allow me to remember what is the critical regions. The critical regions is the region that we should reject. Yeah, we should reject. Yeah, should be the critical region is we should reject. Yeah, reject. Either reject null hypothesis or reject alternate hypothesis. Something like this. Okay. So let's move forward to the motivation of the use p-value. In case of in absence of given significant level, so in this case, for example, we don't know the significant level. Even yeah, we based on the system, yeah, we don't state the significant level, and then once the problem did not give significant level or standard significant level, so we need to determine the p-value based on the statistic. Okay, p-value is equivalent to the significant level actually, but the process, yeah, is different. Okay. Okay, you can see from the table. Actually, I hope from this table it gives you more clear when we use significant level and when we use p-value. Okay. In the conventional, I mean, in the hypothesis testing, yeah, conventional hypothesis testing, usually we use significant level, okay? And then the first steps, first is state the null hypothesis and the alternate hypothesis, and then determine the significant level. Actually, the value is already given, right? And then conduct the statistical tests, and then determine the critical regions, yes, and then reject or accept null hypothesis. And the last one is draw conclusions. Difference to the conventional hypothesis testings, if we use p-value, first we state null hypothesis and then we state alternate hypothesis. It's almost similar. And then, but here, since we don't have a significant level, and then we jump to the conduct test statistic and then determine the p-value. To determine the p-value, and then we reject or accept each null hypothesis and draw the conclusions. Okay. Okay. Maybe not clear yet, but let's move forward to the case. Yeah. Yeah. For example, for this case, we have null and alternate hypothesis as null hypothesis being the mean is equal to 10, and the alternate hypothesis being the mean is not 10. Yeah, is not 10. And then and given standard deviations of population given by the sigma is 1, and then there are two students observed. Yeah, let's see, Joko and Jono conduct statistical tests, and then with same number of sample, it is equivalent that number of sample is 100, and then Joko and Jono have sample average being, this is the sample average of Joko, and this is the sample average of Jono. Until this point, is there any questions about this case? Yeah, about this case. Any questions? No? Yes? No question?
No, sir. For now, no.
Okay. If no, okay. I hope it's clear. And then, if we have a significant value, in this case is using hypothesis testing, yeah? If we have significant value, significant level being alpha being 5% or 0.05, draw conclusions Joko and Jono. Do they have same conclusion to reject or accept null hypothesis? And then using p-value case with no standard with no standard of significant level, it's mean that there is no alpha. And then in this case, in this B, we remove this alpha here. We might arrive at same conclusions. And why? Okay, let's check. Yeah, let's check together. Okay. Or some of you, maybe for the A, is there some of you want to try by explaining? Yeah, hopefully, yeah. Some of you want to explain or wants to answer the A. Wants to answer the A? Want to try answer? And then I will be assist. I will assist you. No? No one tried? Okay. Okay, let's take a look. From the hypothesis case, this is the A is hypothesis case, conventional hypothesis. We don't use a p-value because the significant level has been given. Okay, so we state the here significant level equal to 0.05. And then we can draw the region of hypothesis here. For example, this is the area of null hypothesis. This is 10. So the area of rejections is here. The total is 0.05. So on the left wing or in the left, on the left side will be 0.025. Also 0.025. Until this point, okay? No problem? Okay. And then actually we use different color. The Joko, this is Joko, have 10.187. Okay. Where is the A? This one. Actually, location is here. Here, yeah. This point, 10.187. Okay, the blue one here. And the Chono, 10.187. The location is here. $10.1197. Okay. And maybe some of you asking, how about this point? This point is, I put here, yeah, 10.186. Yeah. It is clear from this result that the Joko, the observation from Joko will accept null hypothesis. But observation from Jono is reject H0 or null hypothesis based on the location of this one and this one. Okay, until this point, any questions? Any questions? Is it clear?
I think still clear, sir.
Still clear. Good. Very good. I love that. Okay. So you can see here the differences here is only, yeah, you can see if if you subtract, jika dikurangkan, ini kan hasil observasinya sangat tipis gitu loh, very much close the gap, but result totally different conclusions. You understand that? Yeah, you understood, yeah? Okay. The delta here, I mean the delta x is very small, yeah, very small, but resulting totally different conclusions. The Joko accept null hypothesis, but for the Jono is reject. Okay. For this point, again, if we base on the significant level, the result is totally not wrong. Is correct. Yeah. This result is no problem. Is correct. Yeah. This correct. Based on this significant level. Okay. This point. Okay. Yeah. And then but some of the, maybe in certain case, yeah, you can see in certain case maybe it is not really correct, yeah. And really correct, maybe if combined with the expert judgment, ya, for example, contohnya begini, misalkan kalau yang ahli sekali, ini dua-duanya tidak masuk seharusnya, kan toh nilainya itu sangat dekat gitu loh. Seharusnya kita mempunyai standar yang lebih tinggi, misalkan standar yang lebih tinggi. Misalkan kalau yang 10, kita harus punya standar 10,001 misalkan. Ini baru kualitasnya bagus. Kalau nilai seperti ini kualitasnya nggak terlalu bagus, komanya. Kalau 001 ini baru bagus nih. Kapan kita menemui situasi seperti ini? Ya, ini berbasis experience, dalam artian tergantung kasus ya. Misalkan apa namanya? For example, for example, weight precision. For example, when we measure the weight of gold. The precision of gold might be gram, gram. How many grams X? And this precision, it should be higher. So it's require maybe something like this. It should be precisely. So in terms of measurement of weight gold, the precision, it should be high. This kind of deviation, this kind of result of observation actually kind of inaccurate observation, for example, and then we need something, this value. Okay, that's the problem, or that's the motivation. And then for example, we again, let's say Joko and Jono, and then Johnny conduct experiment. This is we enter to the B case. Experiment. Okay, and then using maybe a good quality product or using a good quality measurement tools, yeah, and then we arrive at the average sample Johnny being 10,001. And then after that, we compute the p-value. Actually, the p-value, compute the p-value, yeah, it's like computing the probability that, how to say, that the x greater than, x, j, and e, when the, how to say, when the mean is 10, the mean is 10. So in this case, it's like computing the z equal to, this is a z Johnny minus mu, and then we have a standard deviation, so 1 by square root of 10, so it's kind of so it is equal to, this is 10 0 0 0 0 0 1 minus 10, and then this is 0.1, and then equal to what to say, this is 10 ya, 10 berarti ini 100 pangkat 1, ini 10 pangkat min 1, kok 100, 10 pangkat min 2 ya, berarti ini sama aja dengan 0,0 ini 10 pangkat min 3 ya, 001 ya, 001 berarti jadinya seperti ini ya, 0,1, ini z-nya itu 0,1 begitu, z-nya 0,1, and then when z equal to greater than greater than 0.01. Is that correct? Yes. And then we can compute using a calculator, using online calculator, misal for example normal calculator using Kaizen is okay, using so this x is equal to 0.01, x greater than, okay, and then enter screen. And then allow me to stop share screen, and then we move forward to the next one. Yeah, this one, the result. So the mu is 0 and standard deviation is 1, and then we arrive at the 001. 001 for this computation will be, something like the 0.496. So the p-value in this case is 0.496. Yeah, maybe it's too extreme, but no problem. And then we move forward to the very steep. Okay, here the p-value is value equal to 0.496. okay, that's the p-value. That's the view. Any question? Any question, bro?
Sir, so p-value is basically a probability of z more than the value that we find from the experiment.
Yes. Actually, same with the significant level. Actually, you can see here, if we have this one, with the significant level here, this is the alpha, also this is the alpha here. So for the only halving, so is alpha by 2. And the p-value actually this one also. Actually the same as this. So in this case, we can draw the probability, yeah, something like this. So the p-value is p equal to p-value, so it's equal to 0.496, yeah. So it almost half. So if here is 10 and it's around here, so this one is 0.496 per 2, and this one also 0.496 per 2. Oh yes, that's the meaning of p-value here. Okay.
Sir, why we should divide it by 2? I mean, if it's more than that, yeah, why we divide it by 2? I still don't get it.
Okay, that's because mu is not 10. Not 10, so it is possible to not less than 10, or it is possible to be greater than 10. Is that, you get it?
Oh, okay, sir.
Jadi misalkan nul hipotesis itu 10, sebenarnya kan secara statistik ya, secara statistik itu tidak bulat 10 gitu loh. Tidak bulat 10, tapi ada ya kalau 10,00011 ya oke lah, secara statistik ini ekivalen dengan 10 gitu. Nah, gitu kira-kira. Atau 9,9999 secara statistik nilainya itu sama dengan 10. Kira-kira seperti itu. Any question?
Tapi sir, bukannya kalau misalkan kan tadi kan kita ketemu 0,496 ya ketika Z lebih dari nilai Z yang tadi dicari berdasarkan eksperimen.
Iya.
Itu bukannya berarti 0,496 tuh nggak perlu dibagi 2 karena dia udah ke gimana jelasinnya? Karena dia udah ngisi ke semuanya gitu loh maksudnya.
Oh iya, benar. Benar. Sebentar. Ya. Tadi nilai Z-nya itu 0,01 ya. 0,01 Ya. Tadi sebentar. Tadi misal percontohannya adalah hasil observasinya si Joni itu 10,001. Dari sini kita mendapatkan nilai Z. nilai Z oke. Okay. Yeah. Thank you, Hanif. Yeah, I make a correction here. Sorry. So in this case, for the B case, Johnny has from observation result, yeah, the X Johnny is equal to 001, and then we arrive being Z variable being 001, and 001 it is equal to the probability for Z greater than 001, yeah, it is equal to probability 0.496, yeah, 496. So in this case, so in this case, in here, this is in the precisely in the middle is 10, and then for the Johnny observation here is 10.001, and then for this is 0.496. Okay, that's the for for right side. Untuk sebelah kanan, berarti untuk yang sebelah kiri ya di sini, berarti di sini adalah 10 kurangi 00,01 atau ekuivalen dengan 9,999. Okay, and this area is being how to say, is being 0 also, yeah, 496, something like that. So for the p-value equal to, ya ini 2 kali 0,496. Ini almost hampir 1 sih ya, hampir mungkin 299, ini 9. Ya, ini. P-value-nya segini. P-value-nya segitu. Oke. Thank you, Hanif, for your correction. Yes, no need to be divided by 2 because we yeah, this one, because in this case we only inspect in one side, still in one side, and then when we compute the p-value based on this case, we should double. Okay. Any question? Any questions?
Sir, for the p-value in practical problem, we can use our own p-value, right?
Yes.
And then convert it into like a probability.
Yeah. Tapi saya balik lagi ke previous slide here. You should hopefully understand that, ya, ini prosesnya begini. Jadi kalau yang hipotesis testing konvensional dalam hal ini ya umum gitu ya, hipotesisnya biasanya diketahui signifikan levelnya dulu. Signifikan levelnya sebagai standar. Sebagai standar ya, sebagai standarnya kemudian berbasis standar ini kita menentukan akan mereject atau menerima null hipotesis. Oke. Tetapi kalau p-value reject dan accept-nya ini berdasarkan p-value yang diperoleh. Jadi setelah men-state ini kemudian mengkondak tes statistik, kemudian mendapatkan p-value-nya, Nah, nilai p-value-nya ini yang akan menjadi apa sih pertimbangan gitulah, pertimbangan untuk memutuskan di reject atau menerima, begitu kira-kira. Nah, terus mungkin bertanya loh, standarnya reject dan enggak apa dong Pak, gitu kan? What is the basis standard to reject or to accept? Yeah, that's depend on the based on the expert judgment. Usually ya, umumnya kalau menggunakan p-value ini tidak ditanyakan apa namanya, tidak ditanyakan basisnya biasanya, tidak menanyakan apa namanya, dasarnya apa gitu ya, dasarnya ya expert judgment. Okay, any question? Is that clear or not, or still confusing?
Sir, could you please repeat the part where we choose like how to choose the p-value?
How to choose the p-value? Oh, you mean you asked me to repeat this b case?
No, I mean in the real world case, like how to choose a p-value.
How to choose p-value? Actually, p-value is a result of a statistical test.
So based on our result, I mean, what if we get two results? I mean, we conduct two tests and then of course we get two results, right? So how to determine the p-value?
You conduct the two tests and how to determine the p-value.
Yeah, for example, like in the question, there are two person, right? Like Joko and Jono. And then yeah, from Joko and Jono, how to find the p-value, to choose the p-value.
To choose, you mean we should refer to Joko or we should refer to Jono, something like that?
Yes, sir.
Okay. Actually, Joko and Jono will have different p-value. Okay, will have different p-value, and then maybe which better? Which better? Which better is Jono is better. Jono is better because when we have a small p-value, yeah, comparing to this one, so allow me to explain, and then Joko versus Jono. Joko will have own p-value, and Jono will have own also p-value. And then which one better? Which one better? Jono is better p-value. Jono is better, how to say? Better standard. Yeah, better quality. Why? Because the p-value equivalent to the significant level, and then it is equivalent to the error. So smaller error, it means that better system, something like that. Is that clear?
But Jono has like the gap from the average to Jono's value is bigger than the gap between the average value to the Joko value. But why we choose Jono? I mean, Jono has bigger error, right? Compared to
Jono
Joko.
has a bigger error. Jono has a bigger error. No, Jono is no bigger error ya.
Tapi bukannya itu Pak, kan average-nya 10.
Oke.
Terus
Seperti ini
habis iya, average-nya kan 10. Nah, terus Joko value-nya 10,187 sementara Jono 10,197 kan berarti gap antara yang Joko sama average sama Jono sama average-nya kan lebih kecil Joko ya.
Iya.
Berarti itu bukannya harusnya kalau gap-nya lebih kecil berarti error-nya lebih kecil karena dia lebih mendekati 10.
Lebih mendekati 10. Ya, logika itu benar, ya, ya. Logika itu benar, tapi begini. Logika itu benar, tapi begini. If you have this standard, and then the p-value, we will have the p-value equal to 187, 0,187. 187. Satu 187. Jika kita, if we base on this 10.187, we will have p-value around 0.0148. Actually, it's 2 times the 0.374. So that's the final result. Okay. But for this one, we will have the p-value equal to 1,97 itu berapa? So, itu 2 kali 0,2442. It is equivalent to ini 0 equivalent to, sorry. So will be equivalent to times 0.02442. This equivalent to 0.4882. Okay. So you can see here that the p-value, this is the Jono. Jono is correct. And this is a p-value of Joko. So from this p-value, the p-value Joko greater than Jono. What does it mean? Yeah. Yeah. It's mean, let's say people, yeah, or somebody repeat observation again, yeah, repeat observation again, and they get, yeah, and they get a value here, based on the Jono system, it's classified as correct. But if we base on the Joko system, it's classified as wrong or error. So that's why smaller p-value is better.
So we use smaller p-value, so the chance for us to get the correct value or the value that outside the p-value bigger than when we have a bigger p-value.
Yes.
But sir, if we need a strict value, for example, like in the gold case, like you've mentioned before, can we use the p-value for Joko because we need something that is precise, more precise?
So you want to decrease the p-value Joko?
No, I mean I want to use the p-value from Joko because I need the precise value. Can I do that?
You can, but you should increase the number of samples. You got it?
Oh, okay, sir, I get it. So I can increase the p-value, but also increase the sample.
Yeah. For example, how to say, smaller cap. You make a smaller cap here, but when we make a smaller cap, the consequence is making a greater p-value. Means that make a greater chance to be error, right? And then, so how to increase the system? I mean, the accuracy of system. Make a smaller gap, but also decrease the error. So the solution is increasing the number of samples. Yeah. When we increase the number of sample, the probability getting sharper and the error here smaller, getting small. That's the point. Okay.
Okay, sir. Thank you.
Yes, you're welcome. Okay, very good, very good. Okay. Any other questions? Okay. If no question, you have here population variance unknown in case, yeah. It looks similar with maybe 2 weeks ago, yeah, 2 weeks ago. But we extend case to the hypothesis. Actually, the basic known is you already know, yeah. The basic knowledge you already know. But we extend to the hypothesis case. So please try. We show here, I show here the solution step, and just follow the step here, and then you will get the answer. Okay, please try. Yeah, everybody should try. Maybe I will give you 15 minutes. Okay, yeah, 15 minutes, yeah. Please take your time.
Okay, so the level of significance is 0.05. And you can get the degrees of freedom by n-1, which is 12 minus 1. The random sample is n, which is 12. So you do 12 minus 1, which is 11. Using 0.05, the degrees of freedom and the level of significance in the t-distribution table, you can get the value of 1.796. But the critical value is minus because it's below the average. 42 is below 46. Therefore, it's going to be minus. Okay, and compute probability. Okay, this question I used a t-distribution calculator. and the p-value is 0.1345. Yes. Draw a conclusion based on probability. I think it's rejected, right, sir?
Rejected. Yeah. Wait a moment. Why?
Because it's outside of the critical value.
Rejected null hypothesis or rejected the
Failed to
alternate
reject.
hypothesis?
Failed to reject. Yeah, it's failed to reject. Sorry.
So. So
It's failed to reject the H0 is what I meant.
failed to reject H0.
Yeah. Since minus, what's the value? Oh yeah, you can, the test statistic, sorry. I forgot about this, explaining about this. You can get the test statistic value by using the equation, this, the mean minus this, the mu over S over this, which is 42 minus 46 over 11.9 divided by radical 12. You get minus 1.164. This value is used to get the p-value also. I forgot to mention it. And since minus 1.16 is more than minus 1.796, then it's failed to reject the null hypothesis or the H0.
Okay, so the reason why we fail to reject the null hypothesis, why?
It's because the test statistic value is more than the critical value. It's outside of the range of the critical value. That's why it's failed to reject the
Outside.
null hypothesis.
Outside. What do you mean outside?
Like it's more than the critical value.
More than critical value. Actually, not more than. More than critical value. In this case, what is the critical value?
The minus 1.796.
Okay, good. And then the result, observation result, we get the t value equal to?
The p value?
T.
The t value is minus 1.164.
So in this case, is less than or greater than?
It's greater than. The t value is greater than.
Greater than.
Yes.
And because it's greater than, and then you accept or reject?
It's accepted.
Accept.
It's, yeah, right, sir?
Yes, right. That your answer is right, but I want to make sure that Can you show me using graphical representations where we should accept?
How do I draw it? Yeah. I don't really know how to draw it, sir. Sorry.
Yeah, because you said we said the reason is minus 1.16, so your answer is correct, but because of you said the reason is because minus 1.16, I need to see the
maybe
graphical representation of this to make sure.
maybe if it's this
Okay.
is minus 1.1796.
Yes.
And then here is 0.05. So it's this part. Since it's 1.164, then it's somewhere over here, sir, something like that.
So 0.05, where is the 0.05?
Here. Sorry. Over here, sir, over here. I can't see. Something like that. Maybe I should draw it better.
So the location is minus 1.16.
Here. Minus 1.16 is here.
Is here.
Minus 1.16.
Okay. Okay, yeah. Okay, thank you, Ahmad Khalid. Your explanation is correct. Yeah. Okay.
Thank you, sir.
Okay, and then maybe I want to add more explanation. What the Ahmad Khalid said is correct, but why I'm asking about show me the graphical representations. That's because to make sure. But if your reason is the probability, I don't ask more anymore. For example, if you asking the why we let's say after you got it this one minus 0.16 here, and then you got the probability here, and actually is 0.1345, right?
Yes.
And then we should accept or we don't reject. That's because this probability is greater than 0.05, and that's the reason is enough. Do you get it?
Yes. Okay.
Okay, good. Thank you, Khalid.
Thank you, sir.
Okay. Everybody, any questions? No? Yeah, actually, that's the solution here. I already wrote it. You can repeat again for and then. So the previous slide is how to the what Ahmad Khalid already conducted, and then for the next is how to choose the sample size for testing means. Yeah, it's like how to choose the best sample size, yeah, for testing mean. Okay, the motivation first, The choice of sample size is required in the most practical experiments. And problem, how to determine the sample size given by alpha and beta. You remember alpha and beta? Alpha is type 1 error, beta is type 2 error. Okay, the solution first is determine standard deviation of population. Yes, it should be given. Yeah, determine the critical value. Critical value is differ with significant level. Yeah, you can see here the critical value A is like a number cross sections, and then assuming that the means are normally distributed, determine the Z alpha and Z beta given by the alpha, given by the A, alpha and beta. Determine the null hypothesis and the alternate hypothesis, and then determine the first mean and second mean correspond to the each of hypothesis, and then determine the delta is a subtraction or the gap, differences between the mean 1 and mean 2, and then we can conduct or compute the number or sample size is equal to this formula, something like this. And then this is the next slide is proof. Suppose that we wish to test the hypothesis testing like this. The null hypothesis is mu equal to mu 0, and the alternate hypothesis mu is greater than mu 0 with a significant level of alpha, and when the variant is known for the specific alternatives, we say that mu is mu 0 plus delta, that's the gap. The power of our test is shown figure, we will show it. And then for this type 2 error, we compute being like this, and therefore the type 2 error is equal to this one given by the critical value here. And then we arrive at this formula. You can see here for more precise proof, that's the location of A, and that's the area of alpha. Alpha is resulting from the type 1 error. This is the area of hypothesis, null hypothesis, and the more darker, the beta is the beta that is equal to type 2 error. And this area, the white area, but for the second, second probability is equal to H1, alternate hypothesis. And after this, we can prove using these steps, and then we arrive at this formula here. How to choose the sample size based on the hypothesis, something like that. Okay, and then we move forward here. And then this is the new subtopic. It's like a goodness of fit test. The motivation, sometimes it is important to know the probability distribution model of a random variable. Ya, sebagai contoh kita ingin mengetahui, kita misalkan punya random variable ya. Then we want to know this what type probability distribution of this random variable, and we should test it. Solutions: consider and list any possible outcome. The A is the outcome, number of outcome. Conduct the experiment to observe the frequency of each outcome. Compute the experiment frequency each outcome. Determine significant level alpha. Determine critical value, this one. Okay. Conduct the statistical test using this formula. And then we move forward here. For example, here we hypothesize that the D is honest, which is equivalent to testing the hypothesis that the distribution of the outcome is discrete uniform distribution with significant level being 5%. In this case, yeah, there is a this, yeah, this has 6 phases, 1, 2, 3, and another 6 phase. If we consider this is balanced, so the occurrence of each phase will be equal to the probability is 1/6. Correct, yeah? 1/6, yeah? And then if we conduct observation, let's say by 100 time toss, and then, yeah, that's the case. And then the solution is first determine the null hypothesis. The die is uniform distribution, and the alternate hypothesis, the die is not uniform distributions. So first, list all the outcome. In this case, we have 6 outcome, 1 until 6. This one, 1 until 6. Okay, conduct 120 times. Yeah, but it's depend on the, how to say, it's flexible. Larger sample is better. For example, in this case, is 120 times toss. So that's the result. The first phase, we got 20. Second phase, 22. Third phase, 17, and so on until 6th phase. Okay. And that's the result of observation. And the expected observation, expected means that because we expect that this day is balanced. So the meaning of balance, the frequency should be 1/6. Yeah, 1/6 probability. So compute 120 is equal to 20. That's why the result is 20, 20, 20, 20, 20, and 20. Okay. Compute the expected frequency as follows. That's the result of expected frequency. Yeah, that's the result of observe. Yeah, 120 observation, we got this result. And then with the significant value being 5%, so 0 equivalent to 0.05, using chi-square distribution with 5 degrees of freedom, we get the critical value being 11.07. Yeah, it's similar, but in this case, using chi-square distributions. Why chi-square distribution here? Why? Because we don't know the variance. We don't know the variance, and to say, yeah, we don't know the variance, and we don't know the mean. Yeah, we don't know the mean, we don't know the variance. So in this case, we want to know the this random variable that follow chi-square distributions, and then we compute using the formula. Actually, this is the expected value of phase 1. This is the phase 2, phase 3. This is the phase 4. That's the 5, and that's 6, according to this result. Yeah, this one. Okay. And we got this value, and location of this value is here, 1.7. and the critical value is located here, 1.07. And then based on this statistical test, the location of 1.7 is located here, which is inside of 95%. So we fail to reject null hypothesis, or equivalent to we accept null hypothesis because the location is here. Otherwise, if the location is here, we should reject. Okay, reject null hypothesis. Okay, I hope it is clear. Any questions? Any questions? No? If no, it's okay. We arrive at the individual assignment here. Yeah, that's the individual assignment. You can conduct from now or even tomorrow. Tomorrow at 1 p.m. Is or not? Is okay. Yeah, you can conduct from now or just actually this assignment is like for individual assignment. You for tomorrow lecturer, but you can conduct since now. The individual assignment, there are the data of daily new COVID case in Indonesia. Yeah, you can access this, and then the government claims that the average new COVID-19 for daily case is 5,060 case. Okay, based on this claim, government claim, should we accept the claim from the government? Yeah, should. So that's the problem. That's the questions. And I put note here. From this problem, there is no unique answer. It means that there will be many answer. Yeah, will be many answer. So it's not necessary to be equal answer from everyone. Yeah, from one of you. Yeah, so it can be diverse. Yeah, it is possible to have many types of answer. Yeah, so it is possible to you to have a different answer. Scoring is not only based on the method that you use, but also the reason or judgment why you choose that method that way. So in this case, will be two types of score. Method score, based on the method score, is taken from your answer that write on the white paper by hand or by word processor and submitted as a PDF file to a mass. And the reason is the reason or judgment score is taken or assessed by recording your explanation. So in this assignment, you should record. You should explain your answer, why you use that method and why you have that answer. Okay, and upload in YouTube and submit your YouTube link into a mass. So specifically, allow me to show you. You can open the mass, yeah, mass. You can open the mass, and in topic 6, in topic 13, yeah, in topic 13, yeah, in topic 13 you can submit, yeah. You know, you can see here the mask of my page mask. Yeah, you can submit your paperwork for individual assignment and for submit the YouTube link. Yeah, so I can watch your explanations. Yeah, about your answer. Yes. Is that clear for the individual assignment?
What's the YouTube link, sir? For
YouTube link, yeah. After you, for example, you finish, and then you explain your answer, and don't forget to record the video, okay?
So we have to like turn on our camera and explain the assignment.
Yes.
Okay.
Yeah. Turn the camera and record your explanations. After you got the recording file, the video, and then you must upload it in YouTube channel. I think you everyone you have a channel, right? YouTube channel, yeah. In your own, yeah, your own YouTube channel.
Okay.
And then after you upload finish, then you got the link, right? The link, and then submit here, so I can watch. Yeah.
Okay.
Okay. Yeah. So in your explanation, yeah, because it will be assessed, it will be scored. So please, yeah, make a clear explanation why you choose the method and why you choose this number, why you limit it into certain sample size. Okay. And why finally you maybe accept the government claims, or you how to say, you reject the government claim. That's just sample of explanation in your video. Okay, that's all. Any questions? Any more questions? No? If no, yeah. For tomorrow lecturer, we don't have synchronous lecture. I mean, yeah, something like this. We please conduct the assignment tomorrow. So we don't have a class tomorrow, yeah. Okay, that's all my explanation about the individual assignment. And the video I will upload it into YouTube and post it in here. Recording video today. Okay. Thank you very much for your attention. Stay healthy and follow the protokol kesehatan. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
Thank you very much,
Thank
sir.
you, sir.